Alright, in this video I'm going to do a classwork. It's 7.1, so the first electricity homework, number 4 under Coulomb's law. It says that two identical conducting spheres are placed with their centers 0.3 meters apart. One is given a charge of positive 12 times 10 to the negative 19 coulombs, and the other is given a charge of negative 18 times 10 to the negative 9th coulombs. Find the electrical force exerted on one sphere by the other. Okay, so I'm just going to kind of draw a scenario. Again, this is classwork 7.1, number 4. Okay, so you have a conducting sphere here and a conducting sphere here, and you have, this one is 12 times 10 to the negative 19th coulombs, and it's positive. And then here I've got negative 18 times 10 to the negative 9th coulombs, and the distance between them is 0.3 meters. Okay, so it's just a Coulomb's law problem. We're going to take the force electric is equal to K, Q1, Q2, all over R squared. So it's 9 times 10 to the 9th times 12 times 10 to the negative 19th times 18 times 10 to the negative 19th. Oh, sorry, it's not 19, it's 9. Let me cross it off. 9 all over 0.3 squared, right? So let me just go ahead and plug those in. So 9e to the 9th times 12e to the negative 9th times 18e to the negative 9th divided by parentheses 0.3 squared equals, let's write that in citation notation, 1, 2, 3, 4, 5, 2.16 times 10 to the negative 5th newtons. Okay, now there's a second part to this problem. It says the spheres are connected by a conducting wire. After equilibrium has occurred, find the electrical force between the two spheres now. Okay, so we kind of got to understand what this scenario means. Essentially, what's going to happen is you are connecting them by a wire. So the electrons are going to be able to move along that wire. And remember, they want to evenly distribute themselves. So they come to equilibrium where they have the equal charge. So we have to figure out, okay, well, what is the net charge of these two? So we have 12 times 10 to the negative 9th positive, and we have 18 negative times 10 to the negative 9th. So the net charge is negative 6 times 10 to the negative 9th, right? Negative 6 times 10 to the negative 9th. And since they are at equilibrium, they're each going to have half of that. So this one will have negative 3 times 10 to the negative 9th, and this will have negative 3 times 10 to the negative 9th. And that's when they will be at equilibrium. Okay? So then we just have to set up an equation where we have force electric is equal to 9 times 10 to the 9th times 3 times 10 to the negative 9th times 3 times 10 to the negative 9th all over 0.3 squared. And it doesn't matter that these are positive because it's not asking you, it's asking you force between them. If I was asked force relative to this position, then there would be a direction. Or if I was asked force relative to this position, there'd be a direction. But their forces are equal and opposite to one another, so it doesn't really matter. We're just asking the magnitude of the force. Okay. So 9 times 10 to the 9th times 3e to the negative 9th times 3e to the negative 9th. And then you divide that by parentheses 0.3 squared parentheses equals 1, 2, 3, 4, 5, 6, 7. So in this case now we have a force of 9 times 10 to the negative 7th newtons. Okay?